have to unplug everything, move the rig, plug it all back in. Here, everything
piece folds up too.
It all folds up, and then a lot of this is designed too, so when they move, this piece folds over on that, and that's one truck. Instead of having to break it into pieces, you take it out on a separate truck, they can fold this where on top of each other, and it goes out in one piece. All the wires stay together. These are the cylinders of it. Now we can move the rig left to right. Same exact apparatus we saw on the floor, except now we're going in the opposite direction. So this rig can shift over and move this way. Exact same principle, different set of items. Now this is the top of the wheel.
One of these here is
some kind of drain hose. Maybe a drain from the floor down, possibly. Try to use fluorescent lighting wherever they can. You can see both pumps are engaged and pumping. Pumps, those tanks over there are oil, lubricants, things like that. So they're all on another rig, it'd be a piece of equipment kind of sitting off to the side. Here it's all a self-contained unit that moves around. Efficient, makes it move faster, less load. That's what the tanks look like. You go on most drilling rigs, and I don't know why we didn't think about this earlier, most tanks are square. What HMP came up with, and they have a patented technology, you won't see a circular tank anywhere else, is that when you're working with mud and working with mud properties, those things have mixers in the middle that are turning. That's what those generators are. They're keeping the mud stirred up, keeping the properties the same. So if you have a square tank, you've got areas in the corner that obviously aren't getting mixed very well because it's square. Why we didn't think about that sooner, I don't know. They came up with cylindrical tank. That way it keeps uniform mud properties all the time. You'll only see that, as far as I'm aware, you'll only see that on HMP. It seems pretty, should have known, but that's one of the things that came up with. All the wires coming out in the crawler system. So now you're probably 20 feet in the air. The derrick floor is about 20 feet. So this is the drilling floor. This is drill pipe here. So this is what we use to drill the well. All it is these are 30-foot sections. So they're 90-foot stand. There's 3 pieces. So that's 90 feet of pipe standing in the derrick. They just screw into it. See the threads? It's like screwing anything. That thread goes into the other one. So again, we saw at our depth, we had drilled to 8,500 feet. Yeah. So you got about 8,500 feet of, well, minus what's in the hole. They got 5,000 feet of pipe in the hole. So you've got 3,000 or 4,000 feet of pipe standing in there. Wow. You can see they're drilling here. Very different from what we were talking about. When they make a connection, this machine comes out right here. Grabs the top of the pipe, grabs the bottom of the pipe, spins it together, takes it apart. But when they're making connections and they're drilling, there's nobody up here on the floor except in here. They're very different from what you're tripping pipe and everything. Here, nobody, there might be one person out here watching, but there's nobody physically on the pipe itself. The rig does everything itself, and it's all computer controlled from the operator. This would look very similar to what an offshore apparatus would look like. Very different from what no brake handles, no guys up here doing anything. Everything's controlled from inside the drilling.
Is it being driven from the top?
It is. What this is called a top drive. If you remember, what you saw before was called a rotary, where this down here was spinning and turning the drill pipe. On newer generation rigs and things like this, you have a top drive. And what that does is all the power, this is all hydraulic and electricity driven, it moves up and down with the drill pipe. What that allows us to do is, as you can imagine, if we're moving the pipe in and out of the hole, like when you see somebody tripping pipe, if they want to trip pipe and they want to stop and make the pipe move, rotate, they have to stop, engage the slips, and then move it where it's at. They can't pick the pipe up and turn it at the same time because it's all being operated down here. Well, on this, we can move up and down, turn the pipe left or right while we're moving the pipe. So
turn it both ways?
Both ways. So we've got full movement of the pipe all the time. It really helps when you're drilling horizontal wells, when we're trying to make a curve, or if you get into an issue where you've got any kind of hole packing problems, we can keep the pipe moving continuously, where a conventional rig would have to stop on connections, stop the pipe stays stagnant for a time, make your connection and go back to drilling. This continues to drill the whole time, but it's operated from the top, not the bottom. So it just screws in to the top right there, and it moves the pipe all the time.
Does it keep turning while the connection's being made?
It can be, yeah. What they do is they've got another piece of pipe over here. Like when they stop it, when they stab it in, it won't be turning at that point right there. But as soon as they do that, they can go right back to drilling. And so when you're moving the pipe, it really does make a big difference. On connections, all those kind of things, everything's handled by machines out here. So this machine right here is controlled by a computer inside that'll have the machine come out, engage, and make all these connections for it. So there's not anybody out here physically making connections on the
They're sitting in there making connections out here.
Yeah, and I'll show you. It's pretty sophisticated.
Well, that's going to come in handy during the winter.
It does. So nobody's out here freezing. There's no change here. Nobody's throwing anything.
So what are they doing right now? They're not actually drilling though, right?
No, they're just going. Drilling would look exactly the same.
They're just turning and circulating.
They're rotating, and they've got a downhole motor. What a downhole motor is, it sits down on the bottom of the drill pipe. And what you do is as you push fluid down the drill pipe, it's got a stator inside of it that turns. And as it turns that stator, it turns the bit. So you've got two forms of movement. You've got movement of the drill pipe, and you've got a downhole motor that moves as well. So you've got two movements. In this case, there's a downhole motor that's turning the bit very fast down here. It looks like you're not moving the pipe very fast, but you don't need to. Downhole motor's doing everything. So, but the drilling process would look exactly like this. There's going to be no difference. They're rotating the pipe like this, the downhole motor's turning, and you'll see the pipe move down slowly. Mud's being circulated through the pipe, through this big rubber line right here, goes to the top of the top drive right there, and is pumped right down through this apparatus into the top of that drill. One thing that makes this quiet too is the top drive, this big yellow piece of equipment, is actually built into the derrick. In most cases when you have a top drive, it's actually an add-on unit where you actually bolt this thing onto the side of the derrick, and before you move the rig, you actually unbolt it and take it off as a separate piece. The way H&P's designed these rigs, it's actually part of the derrick itself. It stays in the derrick when the derrick moves, and it's got its own track system. So this thing doesn't come off. You don't leave it on there. And what that does is it makes it quiet. Not only do you not have to have a truck to move that piece off by itself, it doesn't. If you can imagine trying to bolt something onto the side of this rig, there's movement. Well, here, as it's an integral piece, there's no movement. It's a stationary piece, so it doesn't make any noise when it moves up and down. A traditional top drive, you kind of hear it move as it went up the derrick. Here, these don't make any noise. It's actually built into. You can see the rails on the side right here. It moves on the structure itself. So when they telescope this derrick in, this thing takes the top drive stays in there, and the whole derrick is moved in one piece.
Do you still have to have a derrick man on top to bring the pipes in when you drill?
You do. I don't believe there is such a thing that moves pipe around. We'll have to ask the guy inside. I'm pretty sure though that when they trip pipe and when they're bringing pipe out of the ground, they have somebody up there. We'll ask them. I'm pretty sure they do. But again, much different than what you're normally seeing. That's the draw works there. So that makes that makes the top drive move up and down through those series of cables there and pulleys. So the cable comes out of here. Again, on a mechanical rig, there would be engines behind that direct drive that. In this case, it's all electricity. Now it's moving down. We did stand here and put it like a connector. On a rig like this, the drilling operation is actually relatively, again, it's all electricity, so all you've got up here are electrical driven components, so it's very, very quiet. Here, if we were drilling on a mechanical rig, you'd have those diesel engines back behind this thing that provide it with power, so you've got engines running on it.